Okay, this is Maths 209, Maths 209, Maths 209. We want to look at what we call interpolation. And so we found out that what interpolation really means is interpolation, as the word implies, denotes, what does it denote? It denotes the method. It denotes the method of computing. It denotes the method of computing the values. It denotes the method of computing the values of a function. That is basically it. So when we say we want to interpolate, you are simply saying what is the method you can use to compute the value of a function. And so we said if y is equal to f of x of any given value of an independent variable, of any given value of an independent variable. Did you see that? Then the variable for example x, then when a set of values of y equals f of x for certain values of x are given. So basically all this grammar we just wrote here is to tell us that interpolation denotes the method of computing values of a function. Now there are two categories of interpolation. There are two categories of interpolation. Two categories. The first category is interpolating with equal intervals. That's the first category. So we said you can interpolate with equal intervals. You can as well interpolate with interpolating with unequal intervals. You can decide to interpolate with equal intervals. You can decide to interpolate with unequal intervals. And so you find out that there are different approach to solving questions that has to do with equal intervals and also that has to do with unequal intervals. So let's look at that. Now okay, let's take this note quickly. We said the study of interpolation is based on the assumption that there are no sudden jumps. It's based on the assumption that there are no sudden jumps. There are no sudden jumps in the value of the values of the dependent variable. Right? So we've been able to learn that interpolation is broken down into two. The first angle is interpolation with equal interval. The second angle is interpolation with unequal interval. And then we have something called the Newton binomial. The Newton binomial expansion formula. The Newton binomial expansion formula. So we said this Newton binomial expansion formula is used in finding missing figures in a table. Is used in finding missing figures in a table. And we said if f of x, or we say y equals f of x, be a function. If y equals f of x be a function which takes the value y0, y1, y2 as we approach yn, we said that corresponds or corresponding to the values x0 plus h, x0 plus 2h as we approach x0 plus nh. You now discover that if one or more values of the function are missing, so basically we use note that we use NBE. So I'm calling this MBE for the sake of the video. MBE in the sense that Newton binomial expansion. MBE in the sense that Newton binomial expansion. We use this Newton binomial expansion to find missing figures. To find missing figures on a table. Missing figures on a table. Okay. Now, recall that when we were treating shift operators, I said that if I have a forward difference of f of x, that the interpretation of this is that the forward difference of f of x plus h should minus the forward difference of f of x itself. It means that change in f of x is the next term minus the previous term. Remember when I drew a number line like this and I said if this place is f of x, then you can liken this place to f of x plus h. You can liken this place to f of x plus 2h as you approach infinity. So I said if they ask you that what's the change in f of x, your answer to that question is f of x plus h minus f of x. So basically where we are going to minus where we are coming from. We are coming from here, right? We are coming from f of x. So where are we going to? F of x plus h. F of x plus h minus f of x is the change in f of x. So we now said that recall that whenever you call e f of x, whenever you say e f of x, it means push f of x to the next person, which is this person. So recall that e f of x is f of x plus h, and so with that you can easily say that the forward difference of f of x is e f of x. So why did I say e f of x? I have switched the definition of this to this. Can you see that? I have switched the definition of this to this. So I'm simply calling f of x plus h e f of x, so minus f of x. And so we now say that the forward difference is equal to e minus 1, because if you cancel out all the f of x here, you have this, right? This is the forward difference equal to the e operator minus 1. This is an identity. Now, because of that, we want to apply that here, the Newton binomial expansion. We want to apply that analogy or that reference. We want to apply it here. So we say that the forward difference of any number which is equal to 0 is the same thing as e minus 1 raised to power n of y naught is equal to 0, because I have proven to you that forward difference is the same thing as e minus 1 in that identity that we talked about. We have been able to prove this to you. So it means that the forward difference is e minus 1 to the power of n of y naught. And so the Newton binomial expansion rule states that, so the formula for Newton binomial expansion states that e to the power of n y naught, yes, minus n e to the power of n minus 1 y naught plus n into bracket n minus 1 over 2 factorial e to the power of n minus 2 y naught plus, as we approach, minus 1 n y naught equals 0. So this is the formula for the Newton binomial expansion, in case you are going to use it. But for the sake of this video, we have a shorter method to solve questions that have to do with missing. I know I said the Newton binomial expansion is used to find missing figures on the table. Although if you want to use this approach, that's fine. Now let's get into the business of the day. And do not forget that this particular formula, which is the Newton binomial expansion formula, is also, you can write it like this. All these things now, the whole formula itself can be written as yn minus n yn minus 1 plus n into bracket n minus 1 all over 2 factorial yn minus 2 plus, as we approach, minus 1 to the power of n y naught is equal to 0. So we wouldn't want to bore you with this formula, so we said let us solve a question that is easygoing. All right, so let's solve a question on this Newton binomial expansion. Okay, let's start with the Newton binomial expansion. Newton binomial expansion. So we said example 1. We said find the missing entry. Find the missing entry in the following table. Find the missing entry in the following table. We said you have a table like this, and then you have x here and you have y's here. So let's just draw this. And we have 0, 1, 2, 3, and 3. We want to find the missing entry. Now this kind of question may appear in your test question. It said find the missing entry in the table, in the following table. We have y to be 1, we have 3, we have 9, we have question mark, and we have 81. So for the sake of this video, we will be using two methods to solve this problem. Okay, so let's start. How do you solve this question? So we said let's label. So step one, you label your table. Okay, so we call this y0, comma, y1, y2, y3, y4. Now we are starting from here. So we are starting from y0, y1, y2, y3, y4. So we are saying y0 is equal to 1, y1 is 3, y2 is 9, y3 is unknown. Did you see that? And y4 is 81. So because of that, because of what we just did here, we can now say that this is equal to the forward difference to the power of 4 of y naught, because you have simply said that this table is 0, 1, 2, 3, 4. You are taking a 4 difference of 4, and so because you are taking a 4 difference of 4, you find out that the Pascal triangle within the system of that is, so let's build a Pascal triangle. What we are doing now is using the Pascal triangle method. Using the Pascal triangle method. So let's quickly look into that. Using the Pascal triangle method. So we said 1, 1, 1. 1 plus 1 is 2, 1, 1. 1 plus 2 is 3. 2 plus 1 is 3, 1, 1. 1 plus 3 is 4. This is 6. This is 4. This is 1, 1. So to the degree of 0, the degree of 1, degree of 2, degree of 3, degree of 4. And so, because we are treating forward difference to the power of 4, we are taking this as our case study. And then we are saying a plus, minus, plus, minus, plus. So, on the table, our labeling starts from in ascending order. But on the Pascal triangle, our labeling starts in descending order. Descending order in the sense that, so let me clean this part quickly. So here we are simply saying that the forward difference to the power of 4 of y naught is 1, 4, 6, 4, 1. But there is a plus here, so that's plus 1. This is minus 4. This is plus 6. This is minus 4. This is plus 1. So our labeling is starting in descending order. So we are saying here should be y naught, here should be y1, here should be y2, here should be y3, and here should be y4. So it means that the forward difference to the power of 4 of y naught is y4 minus 4y3 plus 6y2 minus 4y1 plus y naught. That's what it means. And so if this is the case, forward difference to the power of 4. Now, the question I'm asking, or the question that comes to your mind is, why did I take to the power of 4? It depends on the kind of table you have. This is y naught, y1, y2, y3, y4. If the table was extended, that there's a value here, here will come for y5. So my workings will have been 4 difference to the power of 5 of y naught. And so now that we have been able to construct this, let's start to insert the value. So say step 2 is to insert the values. Step 2 is to what? To insert the values. And so when we insert the values, what do we have? We said 4 difference to the power of y is equal to. So what is the value of y4? Since we have been able to say that y4 is 81, which is this pattern, this value here, 81, right? 81. That would be 81 minus. Now what is 4? What is y3? y3 is unknown, so we just say 4y3. Remember that the whole essence of this thing is to find missing entry. Look at this. Find the missing entry. Find the missing entry. The whole essence of us doing this is to find the missing entry here. And so we said 81 minus 4y3 plus 6 into bracket. What is y2? y2 is 9. y2 is 9 minus 4 into bracket. What is y1? y1 is 3. y1 is 3 plus what is y0? y0 is just 1. y0 is 1. And so we have the 4 to the power of 4 of y0 is equal to 81 minus 4y3 plus 6 times 9 plus 6 times 9, 6 times 9 minus 12 plus 1 is equal to 0. let's equate it to 0. So we said 81 plus now class, what is 6 times 9? 6 times 10 is 60. So what will be 6 times 9? What do you think our 6 times 9 will be quickly? 6 times 9 I believe is 54, right? 6 times 10 is 60, so 6 times 9 is 54. This is 54 minus 12 plus 1. So because we want to just take this to the other side, this is negative 4y3, so we take it to the other side, and then we have 4y3 here, 4y3, and then from here we can be able to say 81 plus 54 minus 12 plus 1. That's 121, 124, and 124 divided by 4. So we said 124 is equals to 4 to the power 4y3. And so when we divide both sides by 4, we have y3 is equal to 31. Very interesting. Very interesting. So we now find out that the value that is missing here is actually 31. 31. Did you see that? The value missing there is actually what? 31. Mind you, what we are dealing with is equal interval. 0, 1, 2, 3, 3. Equal interval. So I said interpolation fall into two categories. We have equal intervals and we have unequal intervals. Did you see that? Equal intervals and unequal intervals. So the other method you can use to approach this question, in case you want to solve this question, another method you can use is to recall. So solution is to recall that the 4 to the power of 4 is e minus 1 to the power of 4 of y naught, right? I told you that this can be interpreted to e minus 1. I told you in the previous video. If you don't understand what this expression is, you can refer to one of the videos where I even explained it today. I said the 4 difference is equal to e minus 1. So having said all of that, we can then say that this expression is likened to e to the power of 4 y naught minus 4e to the power of 3 y naught plus 6e to the power of 2 y naught minus 4e to the power y naught e to the power of 1, because we are reducing 4, 3, 2, 1 plus y naught is equal to 0. Now you may want to ask me how I derived this. How did I derive this formula? Remember that the formula for NBE, Newton binomial expansion, the formula for this is e to the power of n y naught minus n e to the power of n minus 1 y naught plus n minus 1 2 factorial e to the power of n minus 2 y naught plus, as we approach, minus 1 to the power of n y naught equals 0. So what is this n we are talking about? The n is 4, because we are dealing with y naught, y1, y2, y3, y4. So the n we are talking about is 4. So if you factor that into this formula, what you'll be having is e to the power of 4 y naught. We are talking about 4, right? Y naught, y1, y2, y3, y4 minus, right, 4 e to the power of, now what is 4 minus 1? 4 minus 1 is 3. Do you see that? 3 y naught plus, now 2 factorial, as we all learned from year 1, 2 factorial means 2 times 1, which is 2, right? Good. It means that 4 should divide 2, right? 4 should divide 2, and then multiplied by 4, because we are talking about 4 being n. N is 4. So 4 minus 1 is 3, right? 4 minus 1 is what? Is 3. 3. So we have 3 here into the bracket of e to the power of 4 minus 2 is 2. Why not? You know. So now that we are here, we need another person. So what will be the next person? The next person will be plus. So we are saying plus minus, so it should be minus here. It will be minus here. Minus 4e to the power of y naught. If you follow that trend from the formula, plus y naught. So this expression here was how I derived this. This particular expression here was how, following the formula, was how I derived this. Alright, so now it is time for us